Hi folks, this is Jason Burnfield here, and I've got my friend Todd with me.
Howdy.
He's going to help me as the cameraman, and we're going to demonstrate how my collapsible portable 2-meter dish antenna can be fully put together by one person with only a crescent wrench in your hands. So I'm going to hand him the camera and we'll get to it. So, I already stretched these ribs out into a circle, and I put one bolt and nut through the center to attach these two pieces together. But now I'm going to do, there's 3 bolts, one in the center and 2 on the outside. So I'm going to attach them together. This thing's completely collapsible, and it collapses into something that could fit in the back seat of a small car easily, and it can be carried around by one person. The idea was to make it portable and to make it easy to set up and tear down.
It's quite an interesting scientific gadget.
So yeah, it's been an iterative process getting it to work the way that I want, but that's part of the fun of this.
A few iterations.
Yeah. All right. Looks like we got a friendly bumblebee buzzing around here. They don't bother me too much. They may have a nest over there, I'm not sure. Okay, so I've got the ribs all stretched into a circle, and I've got the first and last rib connected together into one piece, and these ropes hold it taut and hold each of the sections to the right distance apart. There's 9 sections, and if you look at the cover, it has 9 sections, and I'll explain a little bit about the cover here. So the cover is made out of paper, and then the paper is the backing, and then I covered the front surface of the paper entirely with aluminum foil tape on the other side, and we'll see that when we attach it and flip the dish over. These bamboo slats are used to keep each of the sections rigid to help the shape stay uniform and help it not to droop in between the ribs. And then it's attached to the frame with these hair tie bungees. I bought them at the dollar store, and there's hook eyes evenly spaced on each of the ribs that then I can stretch and attach the cover to the frame with. So the next thing, after I get the ribs all spread out and the bolts installed in the first and 10th rib, now it's time to start attaching the braces. So there's 3 sizes of braces. There are ones that are 13 inches between the slots, ones that are 12 inches, and then there's a single one that's 11 inches. Yeah, here's my 11-inch one. And because there's an odd number, so they couldn't alternate, it ends up working out that you need a 3rd size for one of them. So the first thing I do is I find the ones with the wide slot is for the rib where there's 2 hooked together, so it's wide, it's twice as wide as the others. And so I'm going to hook the 11-inch rib from this one to the inside slot here, and then I find the 13-inch one that has the wide slot. It goes on this, and then it attaches to the outermost slot here. And then I'm just going to work my way around, and I alternate between 13 and 12. So now we have a 13-inch one here, so now we'll have a 12-inch one here. And then we get another 13-inch. And the interesting thing about this is once we get once we get all the ribs in place, it actually pulls it up into a rigid shape. It's kind of amazing actually, because it really does eventually pulls it off the ground and pulls it into a parabolic three-dimensional shape. Just keep alternating the 12-inch and 13-inch ones. And as I start getting around, I have to raise it up in order to get them into position where it'll fit. There we go. And here's the last one. So, and we make sure that they're all inserted fully. And you'll notice, as I said before, that once you have them all installed, they hold it into the proper shape to where it's kind of freestanding. So now the next step is to insert what will be the top plate. We've got it inverted right now, so it goes underneath. And this centerpiece is coated in foam to give a little bit of leeway so that all the pieces can be held tight. And it has these 3 pipe sections that fit the dowels that will be the rods that hold the focal assembly out at the focal point of the dish, which this is the focal assembly, and it will go on the other side. And then the feed fits right over the focal assembly ring, and when it's assembled, the feed will be exactly at the focal point in the optimum position to receive signals. So got to pull this underneath and position it in the center, and then I kind of push the ribs out so that they fit over the foam, and then I just kind of push them down into place. And then we get the bottom plate, which is just a plywood plate, and I put a flat washer and a nut on.
So you can put this thing together with just a crescent wrench?
Yep. And the only thing I need the crescent wrench for is this one nut. Everything else I can do completely by hand. And I like to tighten it good and tight so that it holds it rigid. Most of the rigidity just comes directly from the slats, but I like to get it tight enough so that it holds it in place enough. Now sometimes the slats will get a little loose, and that's all right. I actually have extra bungees that I put over the hooks to hold the slats in place so they don't fall off when we invert it. And once I get it all assembled and flipped, I'll actually go around, get underneath it, and make sure they're all pushed into place. So now that it's assembled, the frame, now I get inside and I grab it in the center, and I will lift it up and I'll walk it over to the cover and place it over the cover in position. Now I have 2 arrows marked. They're kind of covered with tape, but there's arrows marked on the corner that matches up with the double rib so that I get it in the right position, because these sections aren't all exactly perfectly uniform. There's a little bit of variation, and so I like to make sure I assemble it the same way every time. So I'll walk it over, make sure I step in between and don't crack the ribs. And I try to position it as closely as I can to symmetrical. And then I'll kind of pull each of the corners to get them kind of evenly spaced around the ribs. And then we'll start attaching the bungees to the hooks. And then we'll start seeing the cover actually come into shape against the frame. So the way I attach the bungees, in order to keep each of the sections centered on the rib, I alternate sides so that it holds it tight into the rib. So I put all the first layer connections to the left. It's kind of arbitrary, but I've been doing it to the left, and then I go left, right, all the way up. So I just walk around it now that I've got them positioned, and I stretch them all and attach them on the left side of the rib. And now I'll go around and start attaching the next set on the right side of the rib. And then I'll just keep working my way up as I go until I get all the way to the top. Now the next one's back on the left again.
Now this is a parabolic dish.
Yes.
To detect.
It's used to detect radio signals from what's called the hydrogen line, which is a very low frequency emission line of neutral hydrogen, and it's caused by the spin state of the ground state of the electron. Hydrogen atoms have a single electron and a single proton, and the electron in its ground state, or its lowest energy state, has actually the ground state is actually two states that are really close together in energy. One where the electron spin state is aligned with the nucleus spin state, the other one where it's opposite. And the opposite is slightly lower energy than the aligned state. And so a transition between those two will send out a very low energy photon, which is a wavelength of 21 centimeters, or a frequency of 1420.406 megahertz. And it's a signal that if you have a whole lot of hydrogen, like you have in the Milky Way galaxy, you can pick up a signal from that. And because that gas is moving different directions and it's orbiting around the center of the galaxy along with our solar system and all the other stars that are in our galaxy, the signals from different parts of the Milky Way will be Doppler shifted different amounts in different directions, either up or down, depending on if it's moving away from us or towards us. And we can actually use measurements of how far it's spread out in the spectrum and whether it's how far it's shifted up or down. We can use that then to estimate the structure of our galaxy. And in fact, the very first structural mappings of our spiral structure of our galaxy were made this way back in the 1950s by an astronomer who was making a survey of the neutral hydrogen emissions. So Yeah, so that's what we're detecting. It's called the hydrogen line.
That is so cool.
All right. Now when I get all the way to the top, I have to kind of reach in and grab the center of the cover and pull it up so it doesn't get stuck. So it doesn't get stuck on the wrong side of the plate. And then I got to make sure that the last bungee is on the right side. Or actually, you know what? I've got those on the wrong side. I need to switch them to the left side because the previous one is on the right side. It's not a big deal, but just like to keep them uniform. It's easy to lose track of what you're doing as you're doing this.
Uniform meaning some coherency?
Well, uniform as in I'm doing them all the same direction, so they're kind of, you know, so I don't have them haphazardly connected one way or another, you know. I'm gonna make them all the same. There we go. Trying to keep these, trying to make sure this is pulled all the way up. We're almost through, and then I'll double check that the ribs are all in place, and then I'll put the bungees in place over the ribs to keep them in place. Time to flip it over. So I just attach it from one hook to the other across the slats so that they stay in place. Now I will say this dish performs pretty well at picking up the Milky Way, but unfortunately it's not as versatile as my corner cube reflector in that I can only point it at the zenith. It's difficult to change its elevation setting, and so it's kind of limited in its ability to scan different directions, but it's all right. It's a work in progress, and the fun of it is kind of the experimentation anyway. Okay, I'm flipping it over now. So I'll grab it in the center, kind of work it around, make sure I'm not going to fall on anything. And the good thing is it kind of acts like a parachute, so I can just drop it in place and it's fine. And then I have these feet set up so that they hold the ribs exactly horizontal in the right position, so that the depth of the parabola is set properly. And now what I do is I go around and I try to even out and smooth out the surface as much as I can. Now because the wavelength is 21 centimeters, I can get away with kind of this wrinkly surface because the wavelength is about this long. And so defects in the surface can be as big as 1/10 of that, which is about 2 centimeters. And so as long as I keep the smoothness within that range, it will pretty much behave as a smooth, uniform surface to those waves, because the waves are large enough that they can't really see, you can't really detect imperfections smaller than that size. So at least that's the idea. And I try to stretch out the edges to extend upward with the same kind of smooth curve of the rest of it. And now we're ready to insert the dowels into the pipe slots, or the PVC pipe fittings. So make sure they go all the way down, because it's measured precisely to position the feed exactly at the focal point. I built a tool in Microsoft Excel that does the design work for me. It actually gives me measurement points that I use then to actually measure out and mark out the wood and to get this the right shape. So the design is that it's just over 2 meters in diameter, and the focal to diameter ratio is exactly 0.5, which is optimal for this type of a feed. And so now I'll insert the feed, and I just set it down until it's flat on the feed assembly, and now it's assembled. And now it's ready to actually hook up and take measurements.
That is cool.
So I'd like to thank Todd for doing the filming, and we'll see you guys again soon. Thank you, everybody.
I want everybody to look at that shirt he got for Father's Day.
My daughter gave this to me for Father's Day.
That's
yeah.
beautiful. All right.
All right. See you, folks.
Bye.